Page number 159. Chapter 7. Proportional Reasoning Part 1. A QR code has been provided on the right side of the page, scanning which we can reach out to the additional resources to this chapter. 7.1. Observing Similarity in Change. We are all familiar with digital images. We often change the size and orientation of these images to suit our needs. Observe the set of images given here. Image A, Image B, Image C, Image D and Image E. We can observe that all the images are of different sizes. Which images look similar and which ones look different? Images A, C and D look similar even though they have different sizes. We have images of tiger given on this page. Page number 160. Do images B and E look like the other three images? No, they are slightly distorted. The tiger appears elongated in B and compressed and fatter in E. Why? You may notice the image A, C and D are rectangular, but E is square. Maybe that is why E looks different. But B is also a rectangle. Why does it look different from the other rectangular images? Can we observe any pattern to answer this question? Perhaps by measuring the rectangles. We are provided with a tabular column here which has 6 rows and 3 columns. First column is for image, second is for width in millimeters and third is height in millimeters. Image A has width 60 and height 40. Image B has width 40 and height 20. Image C has width 30 and height 20. Image D has width 90 and height 60. Image E has width 60 and height 60. What makes images A, C and D appear similar and B and E different? When we compare image A with C, we notice that the width of C is half that of A. The height is also half of A. Both the width and height have changed by the same factor. Through multiplication, 1 by 2 in this case. Since the width and heights have changed by the same factor, the images look similar. When we compare image A with image B, we notice that the width of B is 20 millimeters less than that of A. The height too is 20 millimeters less than the height of A. Even though the difference through subtraction is the same, the images look different. Have the width and height changed by the same factor? The height of B is half the height of A. But the width of B is not half the width of A. Since the width and height have not changed by the same factor, the images look different. Can you check by what factors the width and height of image D change as compared to image A? Are the factors the same? Images A, C and D look similar because their widths and heights have changed by the same factor. We say that the changes to their widths and heights are proportional. Page number 161. 7.2 Ratios. We use the notion of a ratio to represent such proportional relationships in mathematics. We can say that the ratio of width to height of image A is 60:40. The numbers 60 and 40 are called the terms of the ratio. The ratio of width to height of image C is 30:20 and that of image D is 90:60. In a ratio of the form A:B, we can say that for every A units of the first quantity, there are B units of the second quantity. So in image A, we can say that for every 60 millimeters of width, there are 40 millimeters of height. We can say that the ratios of width to height of images A, C and D are proportional because the terms of these ratios change by the same factor. Let us see how. Image A is 60:40. Multiplying both the terms by 1/2, we get 60 into 1/2 is to 40 into 1/2, which is 30:20, the ratio of width to height in image C. By what factor should we multiply the ratio 60:40, that is image A, to get 90:60, image D? A more systematic way to compare whether the ratios are proportional is to reduce them to their simplest form and see if these simplest forms are the same. 7.3 Ratios in their simplest form. We can reduce ratios to their simplest form by dividing the terms by their HCF. In image A, the terms are 60 and 40. What is the HCF of 60 and 40? It is 20. Dividing the terms by 20, we get the ratio of image A to be 3:2 in its simplest form. The ratio of image D is 90:60. Dividing both terms by 30, that is HCF of 90 and 60, we get the simplest form to be 3:2. So the ratios of images A and D are proportional as well. What is the simplest form of the ratios of images B and E? The ratio of image B is 40:20. In its simplest form, it is 2:1. The ratio of image E is 60:60. In its simplest form, it is 1:1. Page number 162. These ratios are not the same as 3:2. So, we can say that the ratios of width to height of images B and E are not proportional to the ratios of images A, C and D. When two ratios are the same in their simplest forms, we say that the ratios are in proportion or that the ratios are proportional. We use the symbol 4 dots symbol to indicate that they are proportional. So, A:B is as C:D indicates that the ratios A:B and C:D are proportional. Thus, 60:40 is same as 30:20 and 60:40 is as 90:60. 7.4 Problem solving with proportional reasoning. Example 1. Are the ratios 3:4 and 72:96 proportional? 3:4 is already in its simplest form. To find the simplest form of 72:96, we need to divide both terms by their HCF. What is the HCF of 72 and 96? The HCF of 72 and 96 is 24. Dividing both terms by 24, we get 3:4. Since both ratios in their simplest form are the same, they are proportional. Example 2. Kesang wanted to make lemonade for a celebration. She made 6 glasses of lemonade in a vessel and added 10 spoons of sugar to the drink. Her father expected more people to join the celebration, so he asked her to make 18 more glasses of lemonade. To make the lemonade with the same sweetness, how many spoons of sugar should she add? To maintain the same sweetness, the ratio of the number of glasses of lemonade to the number of spoons of sugar should be proportional. For 6 glasses of lemonade, she added 10 spoons of sugar. The ratio of glasses of lemonade to spoons of sugar is 6:10. If she needs to make 18 more glasses of lemonade, how many spoons of sugar should she use? She can model this problem as 6:10 is same as 18 is to how much? We know that each term in the ratio must change by the same factor for the ratios to be proportional. How can we find the factor of change in the ratio? The first term has increased from 6 to 18. To find the factor of change, we can divide 18 by 6 to get 3. On this page, we have a beautiful picture of Kesang preparing the lemonade in a jug. Some glasses and lemons are kept there. Page number 163. The second term should also change by the same factor. When 10 increases by a factor of 3, it becomes 30. Thus, 6:10 is same as 18:30. So, she should use 30 spoons of sugar to make 18 glasses of lemonade with the same sweetness as earlier. Example 3. Nitin and Hari were constructing a compound wall around their house. Nitin was building the longer side 60 feet in length and Hari was building the shorter side 40 feet in length. Nitin used 3 bags of cement, but Hari used only 2 bags of cement. Nitin was worried that the wall Hari built would not be as strong as the wall he built because she used less cement. Is Nitin correct in his thinking? In Nitin and Hari's case, we should compare the ratio of the length of the wall to the bags of the cement used by each of them and see whether they are proportional. The ratio in Nitin's case is 60:3, that is 20:1 in its simplest form. The ratio in Hari's case is 40:2, that is 20:1 in its simplest form. Since both ratios are proportional, the walls are equally strong. Nitin should not worry. Example 4. In my school, there are 5 teachers and 170 students. The ratio of teachers to students in my school is 5:170. Count the number of teachers and students in your school. What is the ratio of teachers to students in your school? Write it below. You are provided a space here. You are supposed to write the ratio in the blanks. Is the teacher to student ratio in your school proportional to the one in my school? Example 5. Measure the width and height to the nearest centimeter of the blackboard in your classroom. What is the ratio of width to height of the blackboard? You are asked to write down the ratio in the blank space provided. Can you draw a rectangle in your notebook whose width and height are proportional to the ratio of the blackboard? Compare the rectangle you have drawn to those drawn by your classmates. Do they all look the same? Note to the teacher. Give more such examples that students can relate to and ask them to give reasons why they think they are correct. Engaging with these problems and finding solutions through a process of propositional reasoning should go along with learning procedures and methods to solve the problems. Page number 164. Example 6. When Nilima was 3 years old, her mother's age was 10 times her age. What is the ratio of Nilima's age to her mother's age? What would be the ratio of their ages when Nilima is 12 years old? Would it remain the same? The ratio of Nilima's age to her mother's age when Nilima is 3 years old is 3:30. Her mother's age is 10 times Nilima's age. In the simplest form, it is 1:10. When Nilima is 12 years old, that is 9 years later, the ratio of their ages will be 12:39. 9 years later, her mother would be 39 years old. In the simplest form, it is 4:13. When we add or subtract the same number from the terms of the ratio changes and is not necessarily proportional to the original ratio. Example 7. Fill in the missing numbers for the following ratios that are proportional to 14:21. Dash is to 42, 6 is to dash, 2 is to dash. In the first ratio, we don't know the first term, but the second term is 42. It is 2 times the second term of the ratio 14:21. So, the first term should also be 2 times 14, the first term. Hence, the proportional ratios is 28:42. For the second ratio, the first term is 6. On the right side, we are given 14:21 and it is expected from you to multiply 14 by 2 and write the answer in the blank space provided on the left, and towards the right we have to multiply 21 by 2. We are given 42 as the value here on the right side. What factor should we multiply 14 by to get 6? Can it be an integer or should it be a fraction? We can model this as 14y is equal to 6. So, y is equal to 6 upon 14, that is equal to 3 upon 7. So, we need to multiply 21, the second term of 14:21, also by the same factor 3 upon 7. 21 into 3 upon 7 is 9. So, the ratio is 6:9. In the third ratio, the first term is 2. We can see that when we divide 14, the first term of 14 is to 21 by 7, HCF of 14 and 21, we get 2. If we divide 21 also by 7, we get 3. So the ratio is 2:3. Filter coffee. Filter coffee is a beverage made by mixing coffee decoction with milk. Manjunath usually mixes 15 ml of coffee decoction with 35 ml of milk to make 1 cup of filter coffee in his coffee shop. In this case, we can say that the ratio of coffee decoction to milk is 15:35. If customers want stronger filter coffee, Manjunath mixes 20 ml of decoction with 30 ml of milk. The ratio here is 20:30. On this page, there is a picture of Manjunath preparing filter coffee. Page number 165. Why is this coffee stronger? And when they want lighter filter coffee, he mixes 10 ml of coffee and 40 ml of milk, making the ratio 10:40. Why is this coffee lighter? There is a picture of 3 mugs having different levels of milk and coffee in them. The following table shows the different ratios in which Manjunath mixes coffee decoction with milk. Write in the last column if the coffee is stronger or lighter than the regular coffee. Here we are provided with a tabular column in which we have 3 columns and 6 rows. The first row reads coffee decoction in ml. Second column reads milk in ml. And the third column reads regular, strong, light. In the first row, we have coffee decoction in ml as 300 ml and milk is 600 ml. We are expected to write the type of coffee, regular, strong or light. Likewise, in the next row we have 150 as coffee decoction, milk as 500 ml. And we are expected to write the type of coffee we obtain. In the third row, the coffee decoction in ml is 200 and milk is 400 ml, and we are supposed to write down which type of coffee it is. For coffee decoction in ml in the next row is 24 and milk in ml is 56. Which type of coffee will it be, regular, strong or light? And in the last row, we have coffee decoction in ml as 100 ml and milk as 300 ml. We are expected to write down which type of coffee. It will be regular, strong or light. Figure it out. Question number 1. Circle the following statements of proportion that are true. First one, 4:7 is same as 12:21. Second one, 8:3 is as 24:6. Third one, 7:12 is as 12:7. Fourth one, 21:6 is as 35:10. Fifth one, 12:18 is as 28:12. Sixth one, 24:8 is same as 9:3. Question number 2. Give 3 ratios that are proportional to 4:9. You are provided with 3 blanks for the proportional ratios to be written. Question number 3. Fill in the missing numbers for these ratios that are proportional to 18:24. 3:dash, 12:dash, 20:dash, 27:dash. We are expected to fill the filling numbers which are proportional to 18:24 in these dashes. Page number 166. Question number 4. Observe the following rectangles. Which rectangles are similar to each other? You can verify this by measuring the width and height using a scale and comparing their ratios. We are provided with 5 different rectangles having different measurements. A, B, C, D and E are the rectangles. Question number 5. Observe the following rectangle. Can you draw a smaller rectangle and a bigger rectangle with the same width to height ratio in your notebooks? Compare your rectangles with your classmates' drawings. Are all of them the same? If they are different from yours, can you think why? Are they wrong? There is a picture of rectangle here given. Question number 6. The following figure shows a small portion of a long brick wall with patterns made using colored bricks. Each wall continues this pattern throughout the wall. What is the ratio of grey bricks to colored bricks? Try to give the ratios in their simplest form. We have 2 different pictures of walls having different patterns on this page. Page number 167. Question number 7. Let us draw some human figures. Measure your friend's body. The lengths of their head, torso, arms and legs. Write the ratios as mentioned below. Head is to torso, dash is to dash. Torso is to arms, dash is to dash. Torso is to legs, dash is to dash. Now draw figure with head, torso, arms and legs with equivalent ratios as provided here. Does the drawing look more realistic if the ratios are proportional? Why or why not? Note to the teacher. In all these activities, encourage students to reason why their drawings are proportional. Try Rasika, the rule of 3. Example 8. For the midday meal in a school with 120 students, the cook usually makes 15 kg of rice. On a rainy day, only 80 students came to school. How many kilograms of rice should the cook make so that the food is not wasted? The ratio of the number of students to the amount of rice needs to be proportional. So, 120 is to 15 is as 80 is to dash. What is the factor of change in the first term? We can find that by dividing the terms. 80 divided by 120 is equal to 2 upon 3. The number of students is reduced by a factor of 2 upon 3. On multiplying the weight of rice by the same factor, we get 15 into 2 upon 3 is equal to 10. So, the cook should make 10 kg of rice on that day. The situation here is a typical example of a problem where we use proportional reasoning to find a solution. On this page, we have small pictures of a boy and a small toy. Page number 168. 4 quantities are linked proportionally, out of which 3 are known, and we must find the 4th unknown quantity. To solve such problems, we can model 2 proportional ratios using algebraic notation as A is to B is as C is to D. For these 2 ratios to be proportional, we know that term C should be a multiple of term A by a factor say F, and term D should be a multiple of term B by the same factor F. So, C is equal to F into A. Take it as first equation. D is equal to F into B as second equation. So, from first and second, we can say that F is equal to C upon A and F is equal to D upon B. Therefore, C upon A is equal to D upon B. Multiplying both sides by AB, we get AB into C upon A is equal to AB into D upon B. AB into C upon A is equal to AB into D upon B. On cancelling A on the left hand side and cancelling B on the right hand side, we get BC is equal to AD or AD is equal to BC. Thus, when A is to B is as C is to D, then AD is equal to BC. This is known as cross multiplication of terms. Since AD is equal to BC, we can show that D is equal to BC upon A. 2 ratios are proportional if their terms are equal when cross multiplied. The 4th unknown quantity can be found through such cross multiplication. In ancient India, Aryabhatta in 199 CE and others called such problems of proportionality rule of 3 problems. There were 3 numbers given: the pramana, measure A in our case, the phala, fruit B in our case, and the ichha, requisition C in our case. To find the ichha, phala, yield D, in our case, Aryabhata says, multiply the phala by the ichha and divide the resulting product by the pramana. In other words, Aryabhata says pramana is to phala is as ichha is to ichha phala. Therefore, pramana into ichha phala is equal to phala into ichha. Page number 169. Thus, ichha phala is equal to phala into ichha divided by pramana. Using the cross multiplication method proposed by Aryabhata, ancient Indians solved complex problems that involved proportionality. Example 9. A car travels 90 kilometers in 150 minutes. If it continues at the same speed, what distance will it cover in 4 hours? If it continues at the same speed, the ratio of the time taken should be proportional to the ratio of the distance covered. 150 is to 90 is as 4 is to dash. Is this the right way to formulate the question? No, because 150 is in minutes, but 4 is in hours. The second ratio should use the same units for time as the first ratio. Since 4 hours is 240 minutes, the right form is 150 is to 90 is as 240 is to how much? How can you find the distance covered in 240 minutes? Discuss with your classmates and find the answer using different strategies. Note to the teacher. Instead of giving one method to solve the problem of the distance, encourage students to reason out the answer through different strategies. They can use their understanding of equivalent fractions and equivalent ratios to find the answer. We can model this proportion as 150 is to 90 is as 240 is to x. By cross multiplication, we get 150 into x is equal to 240 into 90. Therefore, x is equal to 240 into 90 divided by 150. This on calculating, we get x is equal to 144. The distance covered by the car in 4 hours is 144 kilometers. Example 10. A small farmer in Himachal Pradesh sells each 200 gram packet of tea for 200 rupees. A large estate in Meghalaya sells each 1 kg packet of tea for 800 rupees. Are the weight to price ratios in both places proportional? Which tea is more expensive? Page number 170. The ratio of weight to price of the Himachal tea is 200 is to 200. What is the weight to price ratio of the Meghalaya tea? Is it 1 is to 800? This would not be appropriate because we considered the weight in grams in the case of Himachal. So, the weight to price ratio is 1000 is to 800 in Meghalaya after we convert the weight to grams. To check if the ratios are proportional, we need to see if both ratios are the same in their simplest forms. The Himachal tea ratio in its simplest form is 1 is to 1. The Meghalaya tea ratio in its simplest form is 5 is to 4. So, the ratios are not proportional. Which tea is more expensive? Why? Note to the teacher. Encourage a discussion on the more expensive tea, how they came to their conclusion and what the reasons for that tea being more expensive could be. To answer the question, as to which tea is more expensive, we should compare the price of tea for the same weight in both places. What is the price of 1 kg of tea from Meghalaya? It is 800 rupees. In Himachal, if 200 grams of tea costs rupees 200, what is the cost of 1 kg of tea? Let us say that the price of 1 kg of tea is X rupees. 200 grams is 1 upon 5 of 1 kg. So, 1 upon 5 into X is equal to 200. Multiplying both sides by 5, we get 1 upon 5 into X into 5 is equal to 200 into 5. On solving, we get X is equal to 1000. So, the cost of 1 kg of tea is 800 rupees in Meghalaya and 1000 rupees in Himachal Pradesh. Therefore, the tea from Himachal Pradesh is more expensive. Activity 1. Take your favorite dish. Find out all the ingredients and their respective quantities needed to make the dish for your family. Suppose you are celebrating a festival and you want to invite 15 guests. Find out the quantities of the ingredients required to cook the same dish for them. Figure it out. Question number 1. The Earth travels approximately 940 million kilometers around the Sun in a year. How many kilometers will it travel in a week? Question number 2. A mason is building a house in the shape given in the diagram. He needs to construct both the outer walls and the inner wall that separates two rooms. Page number 171. To build a wall of 10 feet, he requires approximately 1450 bricks. How many bricks would he need to build the house? Assume all walls are of the same height and thickness. Here in the picture we are provided with the measurements of the rooms. Puneet's father went from Lucknow to Kanpur in 2 hours by riding his motorcycle at a speed of 50 km per hour. If he drives at 75 km per hour, how long will it take him to reach Kanpur? Can we form this problem as a proportion? 50:2 is as 75 is to how much? Would it take Puneet's father more time or less time to reach Kanpur? Think about it. Even though this problem looks similar to the previous problems, it cannot be solved using the rule of 3. The time of travel would actually decrease when the speed increases. So, this problem cannot be modeled as 50:2 is as 75 is to how much? Activity 2. Go to the market and collect the prices of different sizes of shampoo containers of the same shampoo and create a table like the one given here. Notice if the volume of the shampoo is proportional to the price. Here we are given a tabular column having 3 different columns. First one is for container, second for volume, and third is about the price. First row has sachets. Sachet 6 ml, cost is 2 rupees. Small bottle, volume is 180 ml and price is 154. Next, medium bottle, volume is 340 ml and price is 276 rupees. Last row, the container is a large bottle, volume is 1000 ml and the price is 540 rupees. Page number 172. Let us compare the ratios for the sample table above. The ratio of the volume of a sachet to a small bottle is 6:180. The ratio of their prices is 2:154. Are these ratios proportional? Why do you think that the ratio of the prices is not proportional to the ratio of the volumes? Discuss the pros and cons of different size bottles for the company and for customers. For reducing ecological footprint, what would you recommend to the company and to the customer? Does the same occur for other products? Make similar tables for other products in the market, capturing different prices for different measures of the same product. Example, rice or atta, that is flour. Observe the products for which the prices are proportional to the different measures. Discuss in class the proportionality of prices to measures of the same product. Note to the teacher. Give a project to students. Start by dividing the class into groups. Each group should go to one shop and collect prices for different measures of the same product. For example, they should note down the prices of 500 grams of rice, 1 kg of rice and 10 kg of rice. They should make tables with measure sizes and prices and present them to the rest of the class. They should discuss if the prices are proportional or not and why. 7.5 Sharing but not equally. Activity 3. Form a pair. Collect 12 countable objects or counters. It can be coins, seeds or pebbles. Now share them between the two of you in different ways. If you divide them equally, what is the ratio of the number of counters with each of you? Each of you will get 6 counters. So, the ratio is 6:6 or 1:1 in its simplest form. Now, let us not share equally. If your partner gets 5 counters, how many objects will you get? What is the ratio of the counters? Here we are given the picture of 2 kids having some counters in front of them and also pictures of counters having numbers as 3 and 9, and then you have 8 and 2, 2 and 10. Page number 173. The ratio of the counters of your partners to yours is 5:7. Now, if you want to share the counters between the two of you in the ratio of 3:1, how many counters would each of you get? Share the counters in different ways and see which combination is in the ratio 3:1. One way to share the counters in the ratio of 3:1 is as follows. First one, your partner takes 3 counters and you take 1 counter. There are now 8 counters left. Second one, your partner takes 3 more counters and you take 1 more counter. There are now 4 counters left. Third one, your partner takes 3 more counters and you take 1 more counter. There are no more counters left. So, your partner gets 9 counters in total and you get 3 counters. When we divide 12 counters in the ratio of 3:1, between 2 people, one gets 9 counters and the other gets 3 counters. Here, there is a picture explaining the ratio 12, the whole is 12. Sharing of 12 in the ratio 3:1 is explained here. We have the whole is 4, that is 3 plus 1, and 12 is 3 times 4. So 3 multiplied by 3 becomes 9 and 1 multiplied by 3 becomes 3. The parts are 3 times the ratio, that is 3:1. Now, if you want to share 42 counters between two of you in the ratio 4:3, how will you do it? Using the same procedure would take a long time. There is a simpler way to share the whole with parts in a specified ratio. You need to divide 42 into groups such that your partner gets 4 groups and you get 3 groups. What is the size of each group? If your partner gets 4 groups and you get 3 groups, the total number of groups is 7. So, the size of each group is 42 divided by 7, that is equal to 6. Multiplying the number of groups by the size of each group, your partner gets 24 counters and you get 18 counters. When you share 42 counters in the ratio of 4:3. Page number 174. Here we have 42, the whole is 42, and sharing of 42 in the ratio of 4:3 is explained here. We have the whole is 7, that is 4 plus 3, and 42 is 6 times. When we multiply 4:6, we get 24. When we multiply 3 by 6, we get 18. So the parts are 6 times the ratio 4:3. In general, when we want to divide a quantity, say x, in the ratio m:n, we do the following. First, we need to split x into groups such that it can be divided into 2 parts, where the first part has m groups and the second part has n groups. Second one, but what is the size of each group? This can be found out by dividing x by the number of groups. The number of groups are m plus n. So, the size of each group is x upon m plus n. Third one, so the first part has m multiplied by x upon m plus n objects, and the second part has n multiplied by x upon m plus n objects. Thus, if we want to divide a quantity x in the ratio of m:n, then the parts will be m multiplied by x upon m plus n and n multiplied by x upon m plus n. We see that m multiplied by x upon m plus n is to n multiplied by x upon m plus n is same as m:n. Example 11. Prashanti and Bhuvan started a food cart business near their school. Prashanti invested 75,000 rupees and Bhuvan invested 25,000 rupees. At the end of the first month, they gained a profit of 4,000 rupees. They decided that they would share the profit in the same ratio as that of their investment. What is each person's share of the profit? The ratio of their investment is 75,000 is to 25,000. Reducing this ratio to its simplest form, we get 3:1. 3 plus 1 is 4, and dividing the profit of 4,000 by 4, we get 1,000. So, Prashanti's share is 3 into 1,000 and Bhuvan's share is 1 into 1,000. So, Prashanti would get 3,000 rupees and Bhuvan would get 1,000 of the profit. Example 12. A mixture of 40 kg contains sand and cement in the ratio of 3:1. How much cement should be added to the mixture to make the ratio of sand to cement 5:2? Page number 175. Let us find the quantity of sand and cement in the original mixture. The ratio is 3:1 and the total weight is 40 kgs. So, the weight of sand is 3 upon 3 plus 1 within brackets into 40. That is equal to 30 kgs. The weight of cement is 1 upon 3 plus 1 within brackets into 40. That is equal to 10 kgs. The weight of sand is the same in the new mixture. It remains 30. But the new ratio of sand to cement is 5:2. So the question is 5:2 is as 30 is to how much? If the ratio is 5:2, then the second term is 2 upon 5 times the first term. Since the new ratio is equivalent to 5:2, the second term in the new ratio should also be 2 upon 5 times of 30. 2 upon 5 into 30 is equal to 12. The new mixture should have 12 kg of cement if the ratio of sand to cement is to be 5:2. There is 10 kg of cement already. So, we need to add 2 kg of cement to the original mixture. Figure it out. Question number 1. Divide 4,500 rupees into 2 parts in the ratio 2:3. Question number 2. In a science lab, acid and water are mixed in the ratio of 1:5 to make a solution. In a bottle that has 240 ml of the solution, how much acid and water does the solution contain? Question number 3. Blue and yellow paints are mixed in the ratio 3:5 to produce green paint. To produce 40 ml of green paint, how much of these two colors are needed? To make the paint a lighter shade of green, I added 20 ml of yellow to the mixture. What is the new ratio of blue and yellow in the paint? Question number 4. To make soft idlis, you need to mix rice and urad dal in the ratio of 2:1. If you need 6 cups of this mixture to make idlis tomorrow morning, how many cups of rice and urad dal will you need? Question number 5. I have 1 bucket of orange paint that I made by mixing red and yellow paints in the ratio of 3:5. I added another bucket of yellow paint to this mixture. What is the ratio of red paint to yellow paint in the new mixture? 7.6 Unit conversions. We have noticed earlier that solving problems with proportionality often requires us to convert units from one system to another. Page number 176. Here are a few important unit conversions for your reference. Length. 1 meter is equal to 3.281 feet. Area. 1 square meter is equal to 10.764 square feet. 1 acre is equal to 43,560 square feet. 1 hectare is equal to 10,000 square meters. 1 hectare is equal to 2.471 acres. Volume. 1 milliliter, that is ml, is equal to 1 cubic centimeter, that is cc in brackets. 1 liter is equal to 1000 ml or 1000 cc. Temperature. Temperature conversion between Fahrenheit and Celsius is a bit more complicated. 0 degree Celsius is equal to 32 degree Fahrenheit and Fahrenheit is equal to 9 upon 5 into Celsius plus 32 and Celsius is equal to 5 upon 9 into Fahrenheit minus 32. For example, 25 degrees Celsius is 77 degree Fahrenheit. Figure it out. First one, Anag mixes 600 ml of orange juice with 900 ml of apple juice to make a fruit drink. Write the ratio of orange juice to apple juice in its simplest form. Question number 2. Last year, we hired 3 buses for the school trip. We had a total of 162 students and teachers who went on that trip and all the buses were full. This year, we have 204 students. How many buses will we need? Will all the buses be full? Question number 3. The area of Delhi is 1484 square kilometers and the area of Mumbai is 550 square kilometers. The population of Delhi is approximately 30 million and that of Mumbai is 20 million people. Which city is more crowded? Why do you say so? Question number 4. A crane of height 155 centimeters has its neck and the rest of its body in the ratio 4:6. For your height, if your neck and the rest of the body also had this ratio, how tall would your neck be? Question number 5. Let us try an ancient problem from Lilavati. At that time, weights were measured in a unit named palas, and nishkas was a unit of money. If 2.5 palas of saffron cost 3/7 niskas, O expert businessman, tell me quickly what quantity of saffron can be bought for 9 niskas. On this page, we have a picture of a crane and a girl having long necks. Page number 177. Question number 6. Hermione is a 1-year-old girl. Her elder brother is 5 years old. What will be Hermione's age when the ratio of her age to her brother's age is 1:2? Question number 7. The mass of equal volumes of gold and water are in the ratio 37:2. If 1 liter of water is 1 kg in mass, what is the mass of 1 liter of gold? Question 8. It is good farming practice to apply 10 tons of cow manure for 1 acre of land. A farmer is planning to grow tomatoes in a plot of size 200 feet by 500 feet. How much manure should he buy? Please refer to the section of unit conversions earlier in this chapter. Question number 9. A tap takes 15 seconds to fill a mug of water. The volume of the mug is 500 ml. How much time does the same tap take to fill a bucket of water if the bucket has a 10-liter capacity? Question number 10. 1 acre of land cost 15 lakh rupees. What is the cost of 2,400 square feet of the same land? Question number 11. A tractor can plow the same area of the field 4 times faster than a pair of oxen. A farmer wants to plow his 20-acre field. A pair of oxen takes 6 hours to plow an acre of land. How much time would it take if the farmer used a pair of oxen to plow the field? How much time would it take him if he decides to use a tractor instead? Question number 12. If 10 rupee coin is an alloy of copper and nickel called cupronickel, copper and nickel are mixed in 3:1 ratio to get this alloy. The mass of the coin is 7.74 grams. If the cost of copper is 906 rupees per kg and the cost of nickel is 1341 per kg, what is the cost of these metals in a 10 rupee coin? Summary. First point. Ratios in the form of A:B indicate that for every A unit of the first quantity, there are B units of the second quantity. A and B are the terms in the ratio. Second point, two ratios A:B and C:D are proportional. Written A:B is as C:D. If their terms change by the same factor, that is if AD is equal to BC. Third point, if X is divided into two parts in the ratio m:(n), then the quantity of the first part is m into x upon m plus n, and the quantity of the second part is n into x upon m plus n. Page number 178. It's puzzle time. Binairo. Binairo, also known as takuzo, is a logic puzzle with simple rules. Binario is generally played on a square grid with no particular size. Some cells start out filled with two symbols, here horizontal and vertical lines. The rest of the cells are empty. The task is to fill cells in such a way that, first point, each row and each column must contain an equal number of horizontal and vertical lines. Second one, more than two horizontal or vertical lines can't be adjacent. Third one, each row is unique. Each column is unique. Here we are provided with a puzzle and its solution on the same side of the page, and we are also provided with 3 puzzles. We are expected to solve the following binario puzzles, and below we have a group of kids wondering to solve the puzzle. Dot grid papers are provided on page number 179 and 180. Chapter 7 ends here.